with it, children. Okay, so this is your open-ended final exam review. So let's take a peek here. So the first problem, given this function, state the end behavior of the function. Now, end behavior, remember, we go based upon the biggest variable, which is an x to the fourth here, and its coefficient, which is 2. So we need to do as x increases and x decreases, or as x goes up or x goes down. Or for infinity notation, as x goes to positive infinity or x goes to negative infinity, what do we do? So we go as x increases, or a positive number. Take that to the fourth power, multiply it by 2. It's going to increase because that will be a positive number back to me. Boom. Let's take and do x decreases. Decreases. Okay, that's a negative number. Take that to the fourth power. A negative number to the fourth power is going to be positive. A positive times 2, positive. So it's going to increase. Or as x goes up, y goes up. As x goes down or goes to the left, y goes up. Because it's a fourth or even exponent, we remember even exponents make parabola-like objects. Alright, let's go forward. P over Q. State the possible list of rational zeros. So, P is 24, Q is 2. All the factors of 24 divided by all the factors of 2. So take all these numbers divided by 1, gives me those. Take all those numbers and divide them by 2. If the number does not appear on the list, like 1 divided by 2 is 1/2, you put that on the list. However, 2 divided by 2 is 1. You already have it. You don't need to write it again. So let's continue there. So this is my P over Q. What do I do with that? Well, then I check that in the next portion, find the actual zeros. You do synthetic division. These numbers right here are the coefficients of the polynomial given to you. Now, what you have to worry about is the following. If you do not have a variable here, like we go x to the fourth, x to the third, x squared, x, and a constant. If there is one of those missing in there, you need a placeholder, which would be a 0. So here the 2, the 7, the negative 17, the negative 58, and the negative 24. We then check numbers from this P over Q list right here from the previous problem in my synthetic division. In order for it to work, it must be a 0 remainder, which means a 0 at the very end. Now, the trick is you need to guess and check these. If it's not 0, try again. You got this. So, what do? I drag the first number down. I multiply. 3 times 2 is 6. Add. Multiply. 3 times 13. Add. And rinse and repeat. So, we go ahead and do that. Now, when you find one that works, we found 3 that works, you then use these numbers as your new coefficients for synthetic division as follows. Look here. We do this because I had an x to the fourth. I found one that works. Now these would give me an x to the third. I find another one that works, like negative 2. Now I have an x squared. You should be able to factor a quadratic. Now if you can't factor it, do synthetic division another time with a 2, a 9, and a 4 as your numbers for synthetic division. Remember, if something is a 0, the opposite becomes my factor. The only caveat to that is once you find all your zeros, the opposite becomes your factor. The caveat I just mentioned, see how we have a negative 1/2 here? You don't see an x plus 1/2. The reason because we don't like fractions in my particular binomial. So if we had x plus 1/2, I would multiply it by 2, giving me 2x plus 1. 3 is a 0, x minus 3 is a factor. Negative 2 is a 0, x plus 2 is a factor. Negative 4 is a 0, x plus 4 is a factor. We go through it that way. Moving on. So, this problem. Let's figure this out. So let's take a look here. And
let's do some math. Let's do some math.
Alright. So we look here and I need to get this radical by itself. So I subtract 4 from both sides first. Now, once I do that, I have to. It's going to be a little tough. I have to then divide by negative 2. Why? This radical needs to be isolated. So what I need to do is get it by itself, like I said. Subtract 4, divide by -2. Boom. Now the radical is isolated. Now notice how my index here is a 5. I then take both sides to the 5th power in order to destroy or eliminate or cancel out that particular radical. Alright, so that falls out, and I have 2 to the 5th becoming 32. I then add 1 to both sides, give me 33. Divide by 2, gives me x equals 33 over 2, or 16.5. You must check your answers. So, put a 33 over 2 in here, times 2, you get 33. 33 minus 1 is 32. The 5th root of 32 is 2. 2 times -2 is -4. -4 plus 4, 0. So this answer over here works. Oh, happy days. Let's keep on moving on. Okay, here. Again, isolate the radical means I subtract 10 from both sides. Boom. I then square both sides because you're like, how did I get a 2? There's no number here. Remember, this number is 2 when not written. So I square both sides. -7 squared is 49. Alright, I then add 5, giving me 54. Divide by 6, giving me 9. Oh, happy days are here again. Except they're not. If I sub 9 back in here, 6 times 9 is 54. 54 minus 5 is 49. The square root of 49 is 7. 7 plus 10, that's not 3. Huh. Ew. This doesn't work at all. So then what I've got to do, what I've got to figure out is why not? It's no solution. Because look, right when I subtracted 10, look here, I have a square root equaling a negative number. That can't happen. If this were a cube root, I'd be fine, but it's not, so I'm not. Uh-oh. So no solution. Moving on to problem 3 here, we see that this is, from chapter 9, one of those problems that's multiplying and dividing rational functions. So, before I start anything, you see that's a division symbol right there? I flip that particular fraction, and only that fraction. So then I flip that fraction and begin to factor each part of each fraction. X squared plus 10x plus 24 factors to x plus 6, x plus 4. You can FOIL it to check. X squared minus 9 is a difference of squares. That's x plus 3x minus 3. Now, these two don't factor. Neither does x plus 6. How did I get from there to here? Well, remember, folks, technically speaking here, there is a 3 out in front of this, because both of these, both the 3x squared and the negative 48, have a 3 in them. If I pull a 3 out, I get x squared minus 16 on the inside, which, oh my, is the difference of squares again. Whoop, there it is. Now, I then cancel. Remember, it's a 1v1 cancellation. You can only cancel out things that are whole factors. I mean, I couldn't go, hey, that x and that x can cancel. No, no, no. They have to be whole factors. X plus 6s, x plus 4s. Now, the x plus 4, this x plus 4 right here, could have canceled out that one. I chose to cancel out that one. Does it matter? No! Thank you, imaginary voice in my head. Doesn't matter at all. It can't do both of them. Only one for one. And the x minus 3s. Look at the bottom, I'm left with an x plus 3, and on the top, this stuff is left over. You do not need to FOIL this out. You could, but you don't have to. It's silly because you might make mistakes. Alright, moving on to problem 4. Ah, the good old banking problems with the formulas given. Thank you. You're welcome, imaginary voice in my head. Alright, so, if I take a peek here, you deposit $2,000 into a bank. That's my principal. Find the base after 5 years. There we go. R is 0.03 because the account pays 3% interest. Remember, 3% is 0.03 as a decimal. Take the decimal point and move it 2 spots to the left from 3. Give me 0.03. That's the number you put into your formula. Interest compounded monthly. Monthly means 12. Now, what do all these variables mean? P is the principal. That's the amount you deposit into the account. R is your interest rate as decimal. N is the number of times you compound your interest. And T is time in years. Now, the only thing is, if I don't get this answer, what I might be doing is not putting this exponent in parentheses. So it needs to be a parenthesis around the 12, one on this side and one on the other side of the 5. If you don't do that, your calculator may multiply incorrectly. Now scrolling down here, now again, T is 5, $2,000, except now my interest rate is 2.5%, which is 0.025 as a decimal. Whoop, there it is. Interest compounded quarterly. That means N is 4. Quarterly is 4. Monthly is 12. Yearly is 1. Weekly is N equals 52. Semi-annually, N equals 2, by the way. Yearly is 1. Things like that. I then go ahead, plug and chug into my formula, which will be given to me. Now the next problem, yearly. All right, 4% annual interest, 0.04, compounded yearly, N equals 1. Going through that nature, no big deal there. Oh, happy days are here again. I don't see the problem. So again, make sure this is in parentheses there. Now, this particular problem, interest compounded continuously. The word continuously, it's N equals infinity. That's not something I could put into this formula. You're right. It's not. When it's compounded continuously, you need to use the PERT formula. It is the only time you shall use that PERT formula. So go ahead and do that. Now the E button is most likely located near the LN button of your calculator, so that's something to look forward to. And you can go from there. Now you're probably thinking, hey, this isn't on my review. You're right. It's not. It's a little extra problem for you. You're welcome. So you deposit $2,000 at 4% interest, compounded continuously. All right, that means PERT formula. Whoop-de-doo. How many years until I get 2,400? All right, so I know P is 2,000. I know it's 4%, which is 0.04. My time is... What? I don't know T. Huh. But I get $24. That means I know A this time? I have to solve for T. Say, what? So I solve for T. And how do I do that? I divide by 2,000 first. Now, unfortunately here, the thing I want is in the exponent. What do? Well, if the variable you want is in the exponent, you need to turn from exponential to log form. So that's what you can do there. Now the log base, you remember, is ln of 0.04t. Divide by 0.04, and there you go. You don't have to round. Leave it like that. Moving on. So this next problem, let's think about this for a second. So what do I have here? I have this particular problem, which it gives me the volume of a sphere. Okay, great. So what do I do with that? That's the question. Well, luckily here they give me volume equals 4/3 pi times r to the third. They tell me what volume is. So this time I've got to solve for r. If any of these problems you're going to have a number of variables, they're going to leave one for you to figure out, kind of like an I Spy puzzle or Where's Waldo. So here, how do I get r to the third by itself? What do? I need to figure that out. Let's take a peek. So you can either divide by 4/3, folks, or I went to the method of multiplying by the reciprocal of 3/4. I then divide by pi, because pi is not a variable. It's a constant number, or a number that's just treated like a variable. Then I get r to the third. This is really important here. To undo that, I am going to take it to the reciprocal power. I'm not going to multiply it by 1/3. I'm going to take it to the power of 1/3. If you could do cube roots on your calculator, you would do it that way, because this is essentially what you'd be doing here. So remember, put this 1/3 in a parenthesis in your exponent so your calculator knows to do that properly. Same with the next problem here. Again, multiply by 3/4, divide by pi, r to the third, take to the power of 1/3. Take to the power of. You are now ready to tackle this particular assignment. Go henceforth and do.
Let's do some math. makes you sad. Hey, yes, I know it makes you mad. Hey, let's do some math. Hey, yeah, we gotta do some math. I had to learn how to do math so I can count all my cash. Hey, let's do some math.